Walk into a modern tomato greenhouse and you'll notice something missing. There is no soil. The plants are rooted in slabs of spun rock fed by tubes, and they produce several times more tomatoes than a field ever could using a fraction of the water. The slabs are made of stone wool, sometimes called rockwool. It's made by melting rock at extremely high temperature and spinning the molten result into fine fibers, a bit like candy floss, then pressing it into blocks. The finished material is sterile, chemically inert, and full of tiny air spaces. It contains no nutrients whatsoever, and that is precisely the point. What it does brilliantly is hold water and air in a very specific ratio right around the roots, so the plant always has both available. The grower isn't feeding the plant through the slab. The slab is just a scaffold that holds the roots in exactly the right conditions. It seems perverse to remove the one thing farming has always depended on. But think about what soil actually is from a grower's point of view: an enormously complicated, highly variable system full of unknowns. It carries fungi and bacteria that cause root disease. It holds nematodes and pests. Its nutrient content differs from one end of a field to the other, and it changes as the season goes on. You can improve soil, but you can never fully know it. Strip it out and replace it with a sterile block, and suddenly every single variable that touches the root is something you chose and can measure. You've traded natural complexity for total control. With the soil gone, the grower has to supply everything the plant needs, dissolved in water. That solution contains nitrogen, phosphorus, and potassium, plus calcium, magnesium, sulfur, and a list of trace elements right down to tiny quantities of iron, manganese, zinc, and boron. It's delivered through a drip line running to each plant. Two things get monitored constantly: the pH, because it governs whether roots can actually absorb each nutrient, and the electrical conductivity, which indicates how concentrated the solution is. Those readings are checked continuously, and the recipe is adjusted, sometimes hour by hour, according to how much light the crop is receiving and what growth stage it's in. The plant is essentially on a drip feed, tuned to its exact appetite. This is where the numbers become genuinely striking. In an ordinary greenhouse growing in soil, producing 1 kilogram of tomatoes takes something in the region of 30 liters of water. In a high-tech hydroponic greenhouse that recirculates its drainage, that can fall to roughly 4 liters per kilogram. The reason is simple: nothing is allowed to escape. More solution is fed than the plants can drink, deliberately so no root ever runs dry. The excess drains out of the slabs, is collected, filtered, sterilized with ultraviolet light or heat to kill any pathogens, rebalanced back to the correct recipe, and sent round again. In a field, surplus irrigation water sinks away into the ground, carrying fertilizer with it. Here, it simply goes back to the start of the loop. The output is difficult to believe if you're used to garden tomatoes. A lower technology hydroponic greenhouse produces somewhere around 28 to 30 kilograms of tomatoes per square meter per year. A high-technology operation can reach 65 to 70 kilograms per square meter. That is an enormous quantity of fruit from a footprint the size of a doormat. And it's why a relatively small country like the Netherlands can be one of the largest tomato exporters on the planet despite having very little land and famously poor growing weather. Part of that yield comes from a growing method that looks bizarre until it's explained. The plants aren't replaced every few months. A single tomato plant is kept going for most of the year, and it just keeps getting longer, often well over 10 meters of stem. It's supported by a string running up to an overhead wire. As the plant grows and the lower fruit is picked, workers release a little more string and lean the whole plant sideways along the row. So the leafy growing tip always stays at a comfortable working height, while the bare lower stem snakes along beneath. Seedlings go in around the end of the year, and that same crop is harvested continuously until the following autumn. One planting, 11 months of tomatoes. The greenhouse controls everything else too. Screens open and close to manage light and retain heat at night. Vents and heating pipes hold the temperature within a narrow band. Many operations deliberately raise the carbon dioxide concentration in the air above normal atmospheric levels, because photosynthesis speeds up when there's more of it, and that alone can significantly lift yield. Increasingly, the whole thing runs under supplemental lighting, allowing production straight through dark northern winters. At that point, you're no longer really farming a season. You're running a factory whose machinery happens to be alive. Two jobs, though, are still done by organisms rather than machines. Tomato flowers need shaking at the right frequency to release their pollen. And it turns out the cheapest and most effective way to do that at scale is to release bumblebee colonies into the greenhouse and let them work the rows. And rather than spraying against pests, most modern greenhouses practice biological control. They deliberately introduce predatory mites and parasitic wasps that hunt the whitefly and spider mites attacking the crop. It's a strange inversion. The most technologically controlled growing environment on Earth handles its pollination and pest control by releasing insects and letting nature get on with it. None of this is free, and it's worth being clear about the trade-offs. Building a high-tech greenhouse costs an enormous amount per hectare, which is why the model only works for high-value crops like tomatoes, peppers, cucumbers, and berries, and never for wheat. Heating and lighting consume serious energy, so the carbon footprint depends heavily on where that energy comes from. Used stone wool slabs have to be dealt with, though they're increasingly recycled back into new material. And there's a long-running argument about flavor, with plenty of people insisting a hydroponic supermarket tomato can't match one grown in soil in the sun. A complaint that has at least as much to do with varieties bred for shelf life and shipping as with the growing method. What it adds up to is a genuine philosophical shift in what growing food means. A field tomato is the result of a negotiation with weather, soil, and luck. A greenhouse tomato is the output of a specified process, where light, temperature, carbon dioxide, water, and 11 separate nutrients are dialed in, and the plant's job is simply to convert them. It uses a fraction of the water and a fraction of the land for the same amount of food. Whether that counts as the future of farming or the end of it depends entirely on what you thought farming was for. Follow along for more of the hidden engineering behind the food on your plate.